Let's talk about the standard headlamp. It's a tool you probably keep in a toolbox or a kitchen junk drawer because it solves a basic requirement. You need light and you need both hands free. But honestly, nobody actually loves using them. The limitation is simple physics. The moment you reach your arm into a tight space to tighten a fitting or grab a bolt, your own hand blocks the beam. You end up working in your own shadow. This chart measures workplace lighting tools based on two variables: quality of illumination on the vertical axis and hands-free convenience on the horizontal axis. Traditional flashlights score well on illumination since you can point them exactly where you need, but they fail completely on convenience because they occupy one of your hands. Standard headlamps solve the hands-free problem, but they drop significantly in illumination quality, exactly because of that constant shadow casting issue. For decades, tradespeople have just accepted this compromise. You either get physical convenience or you get clear visibility, but rarely both at the exact same time. Luminyx is approaching this differently with their NFS-1. They aren't trying to build a brighter headlamp. They are trying to put the light in a smarter location. To understand why, you have to look at the founder's background. Matt Wise is an award-winning cinematographer. He spent over 2 decades lighting feature films and music videos. On a film set, you don't solve poor visibility by just blasting a scene with more lumens. You carefully control where the light comes from to soften harsh angles and eliminate unwanted shadows. His idea was to apply that logic to personal PPE, building an LED array directly into a pair of safety glasses. We need to answer whether this is a clever Kickstarter novelty or a practical tool for serious makers. Concepts that look great in a 3D render don't always survive the grease, dust, and impact of a real workshop. We need to see how the design actually functions under pressure. This animation shows the Circular Illuminated Eyewear, or CIE system. Notice how the LEDs are distributed entirely around the frame's perimeter, rather than relying on a single bulb above the nose bridge. Wrapping the light around your field of view produces an even wash of illumination. When your hands move in front of you, the light simply fills in from the sides, neutralizing the shadows. On our evaluation matrix, the first major feature is the CIE array. The outcome is clear: shadowless light for close-up work. But there is a massive trade-off. Distributing light this way sacrifices long-distance visibility. You get zero beam penetration across a large room. It trades broad environmental awareness for absolute localized clarity on whatever is sitting directly in front of you. Before it acts as a light source, the NFS-1 chassis is built as a legitimate piece of personal protective equipment. It carries an ANSI Z87.1 certification for impact resistance and an IPX5 rating to handle water, rain, and job site spills. By combining these functions, you consolidate 2 mandatory items. You ensure that whenever you need to see a dark workspace clearly, your eyes are already protected from flying debris. Tracking this on the matrix, the ANSI safety frame yields a highly practical outcome: consolidating required gear. The trade-off is rigidity. This form factor forces you to wear full safety glasses even to just check a tripped breaker in your hallway. It enforces strict safety compliance on the job, which naturally reduces its utility for quick, casual tasks around the house. Often, the smallest design decisions tell you if a company actually understands the physical environments their tools are used in. Instead of a built-in battery that forces you to stop working while it charges, Luminyx uses a hot swappable battery system to keep you running continuously through a long shift. And for moments when your hands are covered in grease, wet paint, or sawdust, you can activate the light using touchless gesture controls. Back to the matrix one last time. These operational features give you zero downtime and keep the tool clean. But again, there is a cost. You are now locked into managing a proprietary battery ecosystem rather than just plugging in a universal USB-C cable. You gain extreme physical convenience while you work in exchange for a little extra administrative overhead in your gear bag. So, let's map this directly to your needs using a decision tree. It starts with one question: what is your primary workspace? Let's follow the macro branch first. This covers open outdoor environments. If you are a hiker, a camper, or running search and rescue, traditional tools are exactly what you need. In those macro environments, high lumen distance throw is a mandatory requirement to navigate safely. If distance is your primary obstacle, a standard headlamp remains the most effective and economical choice. Now, let's look at the micro branch for cramped close quarters work. This leads to a second question. Is eye protection required? If the answer is yes, we find our exact target audience. This brings us to professional tradespeople who spend their days working strictly at arm's length. It's built for mechanics reaching deep inside dark vehicle engine bays, plumbers navigating the tight spaces beneath cabinets and floorboards, electricians who need clear visibility on complex wiring inside dense distribution panels, and woodworkers making highly precise, detailed cuts where a harsh shadow could ruin the assembly. For these specific users, the higher price tag translates into an immediate return on investment. It quietly removes a daily source of friction that they've previously just had to accept. Smart tools don't always need to add complex technology to an industry. Sometimes the most practical solution comes from looking at a simple, frustrating shadow through a completely different lens.